Good day to everyone. Thank you so much for joining today's mentoring session. My name is Thomas Basikolo from the ITU, and welcome to this mentoring session. The idea of the mentoring session is that we would like to talk to beginners and introduce some topics that are relevant to the challenge. So if you have some questions along the way, you can just pop up in the chat, type your message or your question, then I'll take it. But also at the end, I hope we'll have some time for the Q&A, so you can just unmute yourself and then ask your question. Right, guess we are good to go. So let's start the session. Okay, let's share my screen. Okay, I believe now you can see my screen. So this is the introduction to communication networks. My name is Thomas Basikolo. I'm working in the ITU, especially on the AI and machine learning 5G challenge. And I would like to welcome you once again to this session. And in this first session of the mentoring session, we are going to discuss about telecommunication networks. But of course, at the beginning, we are starting with the computer networks. What are these computer networks? As we build on these concepts on the telecommunication networks. So to get started, this is the table of contents. You see that we have like quite an interesting agenda. We have the introduction to communication networks. We are going to talk about the evolution of the mobile communication networks, common terms that are used. I will introduce some of the terms that you may see from time to time. We'll talk about network virtualization, a simple architecture, especially the 5G architecture for mobile communication. And then we are talking about the application of AI, as well as the AI and network convergence. And just to highlight, the aim of this session is that we would like, okay, so this session is mainly for beginners to understand the basic concepts of communication networks. And we are going to cover the portions that are really relevant to the challenge. So you may find that maybe we haven't introduced some terms in depth, but of course you can research, at least we give you the skeleton of the concepts that are mainly used in this competition. And of course, we will have some poll towards the end of the presentation so that we can get your comments and ideas. Okay, so let's get started. What is a telecommunication network? So basically, it is a group of nodes that are connected by telecommunication links. And these are used to exchange messages between the nodes. So if you can see here, let's assume that this is a network. So you find that we have two networks here. And in this network in black, you have the nodes here, and then you have the links. These are the ones that are linking the two nodes. And in this case, the nodes can be, it can be a router, for example, or it can be a switch that, and the connections would be like wired or wireless. So in terms of the wired connections, you have the Ethernet cables, for example, if you are talking a home network. So I'll go to the maybe the next slide for kind of a visualization. And you can see that here we have the router, we have the switch, the firewall. So these are nodes. And then you have these links of course, for a home network, we are talking about the LAN cables. And in terms of maybe if you are in a wireless communication, so you have the wireless links, the Wi-Fi communication that takes place. So this is just to look at how the nodes and the links that we are talking about. And if I go back to this, so a network is going to be made up of nodes, which are connection points, such as routers, printers, and switches. And in this case, you can see that we have two separate networks, and these can use equipment from different vendors. If we are talking example, just a simple example of a computer, if you're talking about computers, you have computers that are Windows-based, Linux-based, or you have the Mac-based computers. Networks will have different flavors as well. And these networks also may use separate or different kind of equipment from different vendors, and users are supposed to connect to these networks. So there is an issue of interoperability. And of course, that's where the case of protocols are born. So when we are talking about sending data or receiving data, we need rules to be defined, how this data, or what is the order of the messages, and how this data can be sent across different users with different requirements. So in this case, we have what I've already introduced, the protocols, and the protocols are very important, especially in computer networks or telecommunication networks, because this is how communication is done. So we have different types of protocols. For example, we have the internet protocol, which is IP. If you are using a computer connecting it to internet, you have an IP address. This is the internet protocol. You have the transmission control protocol, TCP. In terms of the web, when you are browsing, you have the secure or the hypertext transmission protocol, or the secure hypertext transmission protocol, HTTP or HTTPS. So there are different types of protocols that are used to make sure that information can be sent properly from A to B in the same network or in different networks. And of course, I think I'm introducing more and more vocabularies or terms. I cannot introduce everything in this presentation, but I hope you have a gist of what we are talking about. You have a rough idea that you can maybe get some, I would say, some interest to read more on these concepts. And another thing I want to discuss is about, I think, the OSI reference model. This is one of the most talked about when you're talking about networking. You talk about this OSI reference model. So what is it? OSI stands for Open Systems Interconnection Model. So it is a framework that is used to describe the function of a networking system. So the networking system, to make sure that everyone don't just do their own thing by themselves and it doesn't work with others, we want to make sure that if you come up with a solution, a networking solution, or if you come up with a device, an end user device, it can be able to work with whatever is already there. So in this case, let's talk about smartphones. Some people have an iPhone, some people have an Android phone, some people have different types of operating system on their phone. But if you are using for example, the Wi-Fi or the internet, you are able to browse to get the pages, the same type of information, but you're using different architecture. So this type of system makes sure that there's interoperability, where some different types of devices can work in the same manner. So this framework or model has 7 layers. You have the physical layer, the data link layer, network, transport, session, presentation, and application layers. So these are 7 layers. And I will just go quickly, like really fast, briefly into the different layers. In the application layer is used by end user software. For example, if you are browsing, you have the web browser. Now you are watching this session on Zoom. So Zoom is also an application. So it's on the application layer and uses different protocol to send and receive information. And this information can be presented in a meaningful way to you. So you have the HTTP, the FTP, and SMTP. So HTTP is for web browser if you're using Chrome or Safari or Firefox, which uses HTTP or HTTPS protocol. And for file transfer, if you are transferring your maybe photos or music. And for simple mail transfer, SMTP is for mails. So if you are, I don't know, Outlook or Gmail or whatever protocol you use. And then in the presentation layer, this will prepare the data for the application layer. So it will define how these, if you are receiving information from another device, it defines how this information is received correctly and also can be presented to you. So it prepares data, especially for transmission over a session, and you have different types of examples that I provided in the slide. And then next one is the session layer. It creates the communication between channels, and these are called sessions, and to make sure that these devices are connecting properly. So the responsibility is to make sure to open a session, a connection session, to ensure that these sessions are open whilst, for example, data is being transferred between two devices, and closing them when the communication ends. And then I would move to the transport layer, and this one takes data transfer in the session layer and breaks it into segments for transmitting at the end. I would move quickly to the network layer, and this has two main functions. One is to break the segments that were formed in the last layer, in the transport layer, into packets. And if it is on the receiving device, it means it's reassembling the packets, and that will be turned into the segments. And also another function is to route packets by discovering what is the best path on the physical network. And we go to the data link layer, and this layer is going to establish and terminate a connection between two physical connected nodes on a network. So it will break the packets into frames and then send them from the source to the destination. Last but not least, we have the physical layer that is responsible for the physical cables, wireless connection between two nodes. And in terms of the transmission of in the physical layer is zeros and ones, or the bits. So this is a quick introduction to the OSI reference model that is really important in networking or communication. And I would move to quickly into introducing the mobile communication and how the evolution from different, I would see different type of communications. So a mobile communication, this is a type of communication between devices in different locations. And you don't use the physical connection such as wires. Because the other type of communication, you have wires, or you have optical fiber or fiber cable, or Ethernet cable, copper cables that you can use to communicate or to send data or send information. But in mobile communication, you use wireless links. And it's been popular over the past few decades. And of course, some of the problem statements in the challenge in the mobile communication domain. So the evolution, quickly, I would go through the evolution of mobile communications from 1G to 5G. The first generation around 1980, I think 1979 is when it was established by NTT Japan, Nippon Telephone and Telegraph Company in Tokyo. And this was the start of the first generation of the wireless telephones. And of course, you had the big size of the phones that were used in the 1980s. And they used analog signals. So the technology was quite limited, and it had like several challenges, especially in terms of low capacity. And it was unable to interoperate between other countries. So you couldn't use it in a different country, only in one country that you can use the first generation phones. And there was no handoff. There was signal interference issues and limited protection from hackers. So it had also security concerns. And then after some time, people wanted to improve on this. So 2G was launched in Finland in around 1990s, 1991. And it introduced a new technology that is called the global GSM, Global System of Mobile Communication. And it became a standard for the future wireless communications. So this enabled digital voice as well as data to be sent across the network. That's when the text messaging started in the 2G. That's where now we are able to send text message to other people because of the improvement in technology for the 2G. Of course, it has its own challenges, especially on low data rates. And also it had very few features that was on the phones. And of course, adoption was low. And then we are going to 3G, where we will see some enhancements. So here was the introduction of Universal Mobile Terrestrial or Telecommunication Systems, UMTS. And this was when the launch of the third generation happened. And in this case, you could transmit a significant amount of data, and also the data rate was, or the data speed was quite high. And some of the features that were introduced with 3Gs, you have like a high speed, up to 4 Mbps of the throughput, and high data rate. You had the introduction of video calling. Your people were able to use their phones to call other people on video, mobile app support, and multimedia messaging support. That's when now we could have smartphones with, for example, WhatsApp. You can be able to use an application to send text or to send images, also to make a video call. This is the 3G. And of course, improved web browsing as well as TV streaming. But of course, it has also its own challenges, especially on the cost of infrastructure and equipment. Of course, the devices, the smartphones are a bit pricey, especially in developing countries, I would say, and also high bandwidth requirements to enable these fast data transmission. So after 3G, then 4G came into play. And this is an enhanced version of the 3G network, and it was developed by IEEE to provide even higher data rates while handling more advanced multimedia features. So in 4G, we had theoretical speeds. I'm saying theoretical because if you go to some other references, you find that the speeds that are quoted are lower. So the theoretical speeds of up to 1 gigabits per second. But of course, in most references, you hear about 100 megabits per second. And you have interactive multimedia video and voice and video calling, HD video streaming and gaming, enhanced security and mobility. So you can have, you are in a high-speed train, you can be able to stay on your phone without facing some handover issues. So it supports mobility as well as reduced latency. And of course, the main difference between 3G and 4G was the introduction of the MIMO technology, which I'm going to talk in upcoming slides, and also the OFDM, of orthogonal frequency division multiplexing. Last but not least, we talk about 5G, and I think this is a very hot topic now. As you already know, 5G refers to the newest fifth generation technology. So in ITU, we don't use 5G, we use IMT. It's a different name, but for the same kind of technology. So it's called International Mobile Telephone or Telecommunications. And you have IMT specifications. So for the 5G, it's IMT 2020, but in the mainstream, people use the term 5G. So if someone says IMT 2020 or someone says 5G, refers to the same thing, just different in terms in terminology. So the 5G is the latest stage in the evolution of mobile communications, and it addresses some of the biggest challenges of wireless technology. So there are three, I think, that I'm going to speak upon, and I would talk about it in detail in the upcoming slides. But you have speed, high-speed transmission, supporting many devices, especially IoT, and also low latency. And the key features is that they should support up to 10 gigabits per second for theoretical speeds, interactive voice and video calling, and you have other, of course, features. So let's talk about the terms that I've introduced, especially for 5G. You have URLLC, MMTC, and EMPP. So ultra reliable or ultra reliable low latency communications. You have the massive machine type communication and enhanced mobile broadband. So in the URLLC, we want 5G to support, in terms of latency, about 1 millisecond user plane latency, and should be high secure, resilient, and should have 99.999% availability. So it means that you can use it for critical situations. So for example, I mean, if you are using surgery, for example, if you are doing surgery using 5G, you need the latency to be as low as possible, but also to be in a secure communication system, and the system should be available at all times. So that's one of the use case. Another one is massive machine type of communications, where you have almost 1 million connected devices per square kilometer, and of course, long battery life, maybe 10 years plus of battery life. And in the enhanced mobile broadband, you have 10 gigabits per second and 4 milliseconds user plane latency and 500 kilometers per hour mobility support. So you have different areas that you need to support, or different applications or use case scenarios that you need to support using 5G. So these are some of the application scenarios, and you can see here, you have what we call the examples that you can check for each user scenario. You have an application that you can use. And continuing with the terms, I'm going to just talk quickly about some other terms that are used. You have the MIMO, multiple input, multiple output. This is type of antenna where you have, or communication system where you have an antenna, the multiple antennas at the input side. So if you have a transmitter side, you have multiple antennas, but also at the receiver, you have multiple antennas. This is to increase the throughput or the data rate. And you can go into the Shannon channel capacity, this equation here, where you have the capacity equals to B, which is the bandwidth, times the log 1 plus S over N. S is the signal power, and N is the noise power, also called SNR. So either to increase the capacity or the data rate, you have to increase the bandwidth, or you have to increase the signal power whilst reducing the noise. So if you have more antennas, it means you increase the SNR. So you have low noise and high signal power, and then the capacity increases. But also another technique is to increase the bandwidth of the channel, and then you increase the capacity. So that's one. And also we have the slicing. It's also networks. Slicing is also an important term that is used in telecommunications so much. So what happens in slicing is that you can have multiple multiple services running on the same network, but you are using it in different ways. So for example, we gave in the previous slide, we have these usage scenarios. You can have a slice that is using EMPP, and you can have a slice, a network slice on the same network, same infrastructure, but using the MMTC, and another slice using URLLC. So these are some of the techniques that can be used, also can be applied in 5G. And of course, I wanted also just to introduce maybe standards, the world of standards. You have the ITU, International Telecommunications Union, that are developing standards. You may hear about ITU, but you don't know what it is, but it's a standards development body. Another one is the 3GPP, or Third Generation Partnership Project. It's a project by different standards body in the world that came together to build standards for 3G, and they went on, they are still continuing building standards. Now the last release was release 18 for 5G standards. And then we have the ETSI, European Telecommunication Standards Institute. And in the ETSI, they have different standards, or different groups that are working on several types of standards. One is ZSM, Zero Touch Network and Service Management. And they are working on safe driving network, in simple terms, autonomous networks, so safe driving networks. And we have the Global System for Mobile Communication, GSM, that I've already talked previously. Another concept that I would like to discuss is on network virtualization. So virtualization, in simple, is to abstract network resources that were traditionally delivered in hardware to be software. So in the past, you had equipment to do every task in the network. So you have the content delivery network, CDN, you'd have the session border controller as a device, you have the, let's say, a firewall as a device, but now with the proliferation of cloud computing or servers, you can abstract these resources as software. So what happens is that you have the physical resources. It can be a physical server, and on this server, either you have a hypervisor and then you have virtual machines, and in each virtual machines, you can run these software, abstraction of this software as a network function. Or you can use containers such as Docker also in a server and abstract these network functions. So these are called virtualized network functions, VNF. And this is a good thing because it's helping advance, especially in the 5G, where most of the functionalities, network functionalities, are abstracted as software. So instead of bringing them as hardware, you just have a data center and you have all the network functions running in the data center as software. So it's good, especially in terms of if you want to upgrade your resources. You don't need to buy a new physical hardware. You can just update your software and you have new updated network. That's the interesting thing about virtualization and virtual functions. Next, I would like to talk about the simplified 5G architecture, or architecture of a mobile network. So I'll start with the core, the 5G core. So this is the heart of the mobile network, and it established reliable, secure connectivity to the network for the users as well as other network providers. So the core network handles really a wide variety of functions. For example, authentication, to make sure that you are who you are, or your SIM card should be able to access some service on the network. So authentication, authorization, subscriber data management, or bidding, and many other things. So we have the mobile core, and this mobile core, or the 5G core, is connected to the internet as well as to other networks. So for example, if I'm in India, for example, I have a mobile SIM for Bharti Airtel. I want to call my friend who is on Reliance Jio. This mobile call for Bharti Airtel is the one that is going to connect me as a user on this network to my friend on another network, which is Reliance Jio. So that's the simple concept. And in terms of how this mobile call can be connected to me as an end user, that's where now we are going. So we have the mobile links, or we can have the fiber optic that connect between the core to the edge server, or you have the microwave links that connect between the core and the fiber. So this is called a transport system. And then at the edge, you have what we call MAT access edge server, or some people just call it edge, 5G edge. And then this is going to connect me, or is going to connect to the base station. So you have, or the cell tower, mostly in most countries, you have the tower that is in red and white, and you have these antennas that are sending signals. And these signals will be sent to the user equipment. So if I'm a user, user equipment could be a smartphone, it could be a smart factory, it can be a connected car, it can be a connected robot, or some robots that are operating in a company or in manufacturing industry, they can be connected to this mobile communication system. So this is the simplified architecture. So this part is called the mobile core, and then you have this part, this part is called the mobile core, and you have the backhaul in the middle, and then you have the radio access network, or front haul. So they run in short. So this is the simplified architecture. And in terms of the framework for this architecture, you have the IMT 2020 framework for the 5G network. So in the network core, you have different functions. You have the capability exposure function, network function registry, user unified subscription management function, session management function, authentication server. You have several functions that are in the core network. And then you have the access network. So this part, right? You have the access network, this part. And then you have the user equipment. So UE, this part where you have the users now. So there are several functionalities that you can see or read about in this framework or in this architecture. And next, I would like to quickly touch upon the OpenRun. I think this is one of the upcoming topics that are hot. And the idea is that OpenRun would like to disaggregate the deployment of front haul and mid haul networks so that it can be built on cloud native principles. Currently, or in most cases, if a telecom operator has a network, they buy equipment from vendors. And most of in the world, it's not a secret, the big vendors, you have Nokia, Ericsson, Huawei, and ZTE. These are the big equipment manufacturers for telecommunications. And if you buy equipment from one of them, most of the times you are locked, you are vendor locked. So every part you use from the same vendor or the same supplier. And what OpenRun is doing is that they would like to split these so that if you have an equipment from vendor X, you can use another equipment from vendor Y and vendor Z, and you can mix all of these, and you can still operate your, I would say, network without problems. So to avoid vendor locking, there is a lot of discussion that is going on in the OpenRun community. If you are interested, I would encourage you to take a look at it. And now, what is AI doing in this 5G or in the mobile communication. So really, artificial intelligence is revolutionizing the telecom industry. There's many use cases, and here I'm just talking about a very few number of use cases that we are seeing, but there's really a huge number of use cases. So it can, AI or machine learning can be used to design the network, or to manage the network, or to plan the network. So you can use AI to detect a fault, or to predict when a fault is going, where and when the fault is going to happen, and also to resolve this fault. You can use AI or machine learning to manage the resources, to schedule or to allocate the resources in the network. Machine learning or AI is being used as well. To save the energy, that's really interesting use case for AI in the telecom industry. Many operators are using AI to save the energy consumption and reduce the carbon footprint. And you have network failure prediction, quality of experience monitoring and optimization, price optimization, and several other use cases that we are providing, especially in the challenge. So let me go to one use case. So in this case, I would like to talk about the graph neural networking challenge. So here, the idea is to create a digital twin, which is a virtual replica of a physical network. And in the graph neural network, the idea is that participants were tasked to design a machine learning model that is trained on small amount of data, up to 50 nodes, but it can infer, or it can perform well to high number of nodes. So you can do inference, and you can predict the performance of a network of up to 300 nodes. So it's more or less like scalability problem. And of course, this generalization to large network that we are not seen before is a good problem for building digital twins. So I think this is a new concept as well. You can look up about digital twin and how graph neural network can help in building these network digital twins. Another one is on radio link failure prediction. And this is in order to support the increasing amount of base station, or in some cases, I talk about the transport layer, where you have microwave links between different areas where there's no optical fiber. So in this case, when you have microwave link, weather changes also affect the performance of these links. So in this problem statement, participants were given weather information, and so it can be if it's rain, snow, or fog, and the predictions for the future. So weather predictions. So by using weather information from the past and the predictions of the future, you should be able to predict whether this radio link is going to fail or is not going to fail. So it was also an interesting problem statement that we provided in this challenge. And to sum it all, I would like to just talk about different problem statements we are covering this year. So, and where in the simple network architecture, where these problem statements are located or are affecting. So between the base station or the transmitter and the user equipment, you have the beam prediction challenge, you have the throughput prediction, and beam classification, and federated traffic prediction. So these are the 4 problem statements that are in this area. And at the user equipment side, you have the network user classification, another problem statement that we are offering this year. On the base station itself, we have the amplifier behavioral modeling. And in the, I would say, 5G core, or on the edge, or multi-access edge compute, MEC, you have the buildathon, or build your own closed loop problem statement, as well as data generation using GANs. So really, you can see how there's mapping between different parts of the network and what we are offering in the challenge. And yeah, so this is quite a simple presentation, and it was quick because of the timing, and there was so much concepts that we have introduced. So a big thank you to my colleagues who has helped to come up with some of the materials that we have presented today. So yeah, you can join the conversation, and thank you so much for being there listening, and we can open now for Q&A. So any questions, any comments? Maybe Vishnu, you can kick off with some simple explanation or additions.
No, first of all, thanks, Thomas. Excellent talk. Thank you very much. There is a question here. Warren is asking, how would one classify non-network system with OSI model? I mean, there is really no. I mean, the way Thomas explained, right? It is the OSI model comes in the picture where there is interoperability problem, and also where there is these reference points and the links between the nodes, right? So really, if it is a non-network system, it doesn't come into picture. However, I mean, there is one more way to look at it is, are there quote unquote moving pieces, right? So moving pieces in the sense the vendors, open source, whoever is providing the software or the controller. In your case, you're talking about an offline microcontroller. So whatever goes inside it can be provided by different providers, let me call it, because it can come from vendors, it can come from open source, you may put it yourself. So it can come from different sources. So they have to work together in the microcontroller in your case, and in a cloud data center in the other side of the scale, if you will, right? So you are talking about an offline microcontroller, which is probably very small, but you may actually come across at the cloud data center, which can be very big. So irrespective of the size, you may hit the interoperability problem, in which case this may be still be applicable. So the reference points may be internal, but they still may be there. The stack may still exist, but that's not over the wire or over the reference point, if you will. So that's one way to look at your question. But in general, that is, if there are no moving parts, if there is no interoperability, then obviously there is no protocol involved. There is another question about competition format. I will leave that to you, Thomas. There is another question about problem statement details. I put the link just now. Who is asking? Haider is asking. So you can check the link in the one which I put just now, and you can get the problem statement details from there, and also you can get the data sets once you register for it. Alice is asking, how do you overcome much attenuation where I believe there is line of sight is not feasible, and still have a solution that is perfect where when AI ML is introduced? That's a good question. So yeah, attenuation, well, I wouldn't worry too much about attenuation, but signal strength, right? So let's talk about signal strength in general, right? So if you are worried about getting a good quality signal, that is an important question. Coverage is an important question. So there are multiple ways to do it. One way is small cells. In 5G, we look at small cells. So we provide coverage with small cells. So that's one way to look at it. There are other ways to look at it, like Thomas touched upon MIMO, beamforming. Such techniques exist. So we can cover that in a later session. What else am I missing? Yeah, so there may be other techniques in the sense of mobility optimization. So that's another way to optimize coverage and to provide good signal strength to the mobiles. And all this involves algorithms. All this involves data training, model training. That's where AI/ML comes into picture. I think one of the problems that Thomas explained, there is radio link failure prediction. That's actually a good example. I think there is one, Professor Ahmed is actually hosting a problem statement from Arizona State University. That's also a very interesting problem in this area. Take a look. Yeah, thank you. Submissions can be, thank you. Link, okay, link does not open. So yeah, so I believe you can try a couple of tricks. You can try with Chrome if you have it. Otherwise, you can clean up all cookies and try it. It is working for me as the last time I tried. Where can we find the recorded sessions? So yeah, that's also for you, Thomas. Yeah, that's all I see. Maybe two questions for you, Thomas. One on the submissions, deadlines, and maybe what is that about? Rushat is asking about deadlines and maybe about formats, right? And then another one about recorded sessions. Yeah.
Okay, thank you so much. First, we have launched the poll. So if you haven't answered, please answer the poll. It will help us to see what we can do in the future. And in terms of the question about the submission, each problem statement has different submission deadline, but of course, the most problem statements, their submission deadline is 28 October. So just check on the portal, when is the submission deadline? That's the first thing to check. If you are not sure, you can always email us and we will guide you through that process. The next one about the challenge, if it seems some people have problems accessing the challenge portal, but in my case, I'm able to access it. So it might be, maybe you can check your cookies or something like that in case there might be some issues. Okay, the recording. Yeah, we have recorded the session, so we will see how we can make it available in the coming days to other participants. So you can check information on our website or on our Slack page where we can update when the session is available. We are also planning to have another session related to data pre-processing for machine learning models. So please be on the lookout and check our messages, especially email messages. We'll send a date and then you can join to these. Okay, in terms of showing the web page. Okay, so let me share my page. Just a moment, I need to get some information here. Okay, so here is the page. So when you go to the page here, first, if you are not registered, you have to register. You create your username, password, what. Once you register, you can log in. And when you go to problem statements, you find several problem statements of the sliding video, classification, multimodal, beam predictions, smart weather. You have several problem statements that you can choose from. So, for example, if you choose synthetic observability data generation using GANs, you have the description here, the evaluation criteria is here, the data source, resources, and contact. And you can see that here is the competition phase and evaluation phase, and of course, submission of deadline will be around here, 10/28, so 28 October. So you can join these kind of different type of projects that you are interested in. So I hope this is okay for you. Any other question? Otherwise, we can connect via Slack. We can connect via emails, and of course, you can see our information on the challenge web page. So thank you so much, everyone, for joining, and I'm wishing you a very good day.